Hello everyone, welcome to the channel. My name is Gaurav Singh from Automation Hacks, and in this video we are going to take a look at Java 8 streams. Java 8 streams is one of the most heavily used features when it comes to test automation. The general thing goes is you always work with some or the other collection, like either a list or a hash map, and often you have to iterate in that list, find out certain items in that list, or also manipulate the data. So let's take a look at how this works. Right now, I have an example class called as stream test. And just to set up the test here, I have a list of some names, right? We can see we have a list of 4 different people. There is a duplicate here as well, which we'll use later on. And let's understand how do we first create a stream. So there are a couple of ways that you would potentially create it. So here is one example. Suppose you have a string array with certain strings in it. You can create a stream object out of it directly by using arrays.stream and provide it an array, and it will in turn give you a stream with the data type that is for that given array, in this case string. Now, another way is you can directly use stream.off and provide it a list of values directly, sort of like args, and this will also give you a stream. Just to ensure that these streams are okay, here I have an assertion where I'm checking that if I convert the first uh, stream into a list, and this is a way, the toList operation is a way for us to directly convert a stream into an immutable list of items. Similarly, I'm checking that this particular list should contain any of the elements from another stream, which was the second one that we created. We can see that both of these streams are identical, so I'm expecting this test to pass. Yes, and we can see this test passes. Cool. So now we know how to create a stream. Let's understand how do you create a parallel stream. Now, this is extremely useful in case you have a large data set that you want to iterate upon and do some operations. In that case, doing it sequentially might not be optimal. So you can rather use a parallel stream. What this would do is it would iterate and possibly try to create a parallel stream where you are able to iterate in that stream in a much faster way. If you go to this function, you can see that this will try to return a possibly parallel stream with this collection as its source. Uh, so that's exactly what we are looking for. So now here, what I want to do is nothing fancy. You remember the list of names that I have on top as an array. What I want to do is I want to convert each of these names into uppercase, and I want to do it faster. So I'm going to use a parallel stream on this names list and then use the map function. Now here is our first introduction on how to apply different functions to different items in a stream, right? So what I want to do is for each element in this stream, I want to apply a function. And here, as you can see, I have applied method references. So I've provided the string type, given double colons, and then given two uppercase. Finally, I want the result in another list. So I'm using the toList method as a way to collect all the manipulated inputs into an immutable list, store them in updated. Don't be confused with this var keyword. We will look at that in later versions of these videos. This was a newly introduced feature in later versions of Java. And then I want to make sure that if I join the updated list, so I use the string.join method with just a space, then it gives me the list with the names of people, but in uppercase. So let's just run this test. And this is also working fine. The test also works very fast. While working with this, try to make sure that there are no side effects created by whatever you are doing. So in case there are, say, you're trying to do a DB operation, make sure that the DB class is supporting concurrent operations and whatnot. Nice. So moving to the next thing is another beauty of using Java streams is that you can technically chain methods one after the other in order to get a different outcome. So let's see an example of this. Continuing with the same names example, what if I wanted to only find the distinct number of names in that list? Now, this could be useful even in automation when you have, say, multiple duplicates and you want to eliminate them and do some operations, right? So I'm creating the stream like always, given that list, and then I'm calling the distinct method followed by a count method. So there are multiple such methods available on a stream. If you try to go here, you can see you have multiple such methods. And of course, I'm going to cover some of them in this video, but feel free to also do your own exploration whenever you feel a need of, achieving something on a collection, then chances are that that method might already be implemented. So now, given that the above list had duplicates, right? James is repeated twice. What I'm expecting is that the distinct method should be able to only give unique elements, and then the count method should be able to give me a count. So here I'm expecting in the end that the count should be equal to 3, right? Let's run that. This is okay. Cool. Now, where we have understood how to create a stream, how to work with a parallel stream, and also know that we can chain methods. What next? So we can also use certain methods while we are iterating into a stream. So for example, say in an automated scenario or a test, you want to make sure that you are able to check whether a given list has a certain element. This is often the case when you are, say, querying the DB and want to check whether the results have what you're expecting it to have, right? So here, another method that you can use is any match, which basically will take a lambda function and it will return a result if any of the elements in the list actually match this function. So here I'm passing the element that I want to iterate, and I want to check that is there any element in the list which basically contains the string Steve. And looking at our list above, we know it does. So this assertion should pass. I'm just checking whether this Boolean returns true. Yes, it does. Cool. So we know how to iterate as well. Now looking at how do you filter elements in a list. Now this is a very common use case. Say you are getting a list of records from an API response and you want to only filter it to a certain object within that list, which is basically the test case that you're looking to automate at a given point of time. So here you can again start the stream the same way, and you can use the filter method, which will make sure that it will all filter all the elements that actually match this predicate or this lambda in this case. So here I want to make sure that I am able to filter uh, all the Jameses from the list, right? So I'm passing lm, which is basically the current element that will be used by the stream to iterate. And then I'm checking if it contains James, then yes, I want only those records from the list. And in the end, I also chain a count. So I want the number of times James have appeared in this list. We know that seeing this list, it has appeared twice. So we are just checking that this is equal to 2. And let's just check. Yes, this as works as well. All right, so on to some fun stuff with streams. Now, streams can be used to actually map functions and apply a complete function to a list. We saw an example of this above where we are trying to, uppercase the elements and multiple other things, but you can also define your own custom function. So let's see an example of it. Say you have a list of some file paths, but these file paths are missing a parent directory that you want to append or essentially prefix in front of every one of them. Well, we can achieve this via streams. So we again start a stream on this list and then use the map function to provide what function we want to call on each element in this list, right? As we are iterating in them. So now we have the current element that we want to iterate on, and we provide a format string where we have given the placeholder percentage %s, uh, likewise another percentage %s, and use the formatted method in order to provide the arguments. So here I'm just hypothetically adding like a base path for some user in a Mac environment or a Unix environment, and then I'm passing the current element. So what I'm essentially expecting is for each element, we should be able to prefix this. And then I want to collect the results like always to a to list to give me like an immutable list. Now, in the end, let me just join this and print it, right? So I'll use the logger that I created above to just print this output, and let's see what it gives. So as you can see, for each of these paths, we have prefixed a certain string that we care about. Now, this could be replaced with any sort of operation that you want to do on a stream. Uh, the sky is really the limit. And as long as you're able to use Lambda functions, you are good, right? Um, Cool. So, another common use case while working with streams is sometimes you want to create a flat map. Essentially, if you have a list of, say, objects, wherein each of these objects themselves are kind of having nested keys, and you want to essentially sort of reduce them into a flat map, then you can still do that. Let's take an example of how we do it. Now, I'm jumping a little bit and introducing a concept in Java that we have introduced in later versions and which we'll cover in these videos as well. But for now, just understand that Java introduced a new concept called as record, where we can create a data holder of class sort, and it generates constructor and getters for us automatically. So I have an inner record called as person, which has two attributes. One is a name with a type of string, and it has a list of strings called as moods, right? Essentially, what are the moods the person is having on that particular day. So let's say we have two peoples. We have a list of two new persons. One is John. John is very angry, happy, and sad at the same time. I'm very curious on what is going on in his life that makes him so. And Jane is more adventurous and calm. Kind of contradictory, but yeah, this is a hypothetical example. Now, what I want to do is I want to convert this nested list into a rather a flat list. So what I can do is I can use create the stream again and then call the flat map, which will take every element that I'm caring about, and it will convert it into a stream and give me the stream in return, like flat modes, right? So now what it will do is it will iterate in each of the elements and then extract that stream out and flatten it, right? Now, just to make sure that this works as we are expecting, let's join this using the string dot join separated by a comma and see what this flat modes gives us as a result, right? And we log it. And essentially what I'm expecting is it should be able to extract these nested values into a flat sort of list, right? Using the stream. So I'm expecting all the moods that both John and Jane basically experienced. And let's run this test. Yes. So as you can see, it did do the job of essentially flattening any nested values. This could be useful in case you don't really care about duplicates in a nested object and you want to just extract or flatten a nested object. Sometimes very useful in automated tests. Nice. So we are kind of on a roll. Let's continue with couple of more examples here. So another thing that streams can do very well is actually match, right? And we saw an example of that above where we tried to find, any match in a list of or a stream of strings. So here is the same example again. Say you have an empty list and I want to just check that this empty list of strings basically has an empty string, right? So I'm checking like, is there any element in this list which is empty. And again, I use the method references syntax here, and I'm expecting it to be true. And continuing on, like say I want to be very strict and I want to make sure that a certain list has all the elements that I care about, right? So I have a list of names like Tango and Charlie, and I want to make sure that all of these elements do have the character A in them. So I can use an all match, which is basically a way to say that all the elements should adhere to this predicate, right? In this case, we have lm, and I say that, hey, every element should contain A, right? And I check at the end whether it does return true. That is something I expect. Uh, Also, you can have an inverse of that as well, wherein you want to say that, hey, none of the elements should contain something, right? Just as a hypothetical example. So, yeah, none of the names should have the character X, and I also expect it to be true. So, let's run this. The test passes. So this is a good way for you to do sort of checks on your list that you're working with using streams. This is extremely useful when you are having to do some assertions based on any response that an API or anything else might be returning. Quite useful. And the last thing I want to cover actually is that using streams, you can also reduce the elements. So what is an example of that? So say I have a random list of numbers. So I have a new array list of integers type, and I use a new sort of factory that was introduced in the later versions of Java here, where I'm using a random generator factory of type random, using the create method and using it to create 10 different integers. And for each of these integers, I'm also adding it to the list that I created above. So essentially, I'll iterate in all of these numbers, and then I'm going to use the method reference random numbers colon colon add. And now, say I want to give like a starting number, like say 10, and I want to make sure that as I iterate in this random list of numbers, I'm able to total them, right? So one way is, of course, you can use a simple for loop and add each number as you iterate in them. That's a simple way of doing it. Streams also allow you to use a reduce function, which is a very popular function if you're familiar with map, filter, and reduce sort of constructs in functional programming. Essentially, given a particular input, you want to apply a function and keep on reducing the value, right? So how it works is you give a starting value, which is 10 in this case. And what you want is, as you iterate in this stream of numbers, you call a certain function, which is nothing but integers sum method, right? So what you're telling here is, given this accumulator value that you have given at the start, just keep on applying this function on all the numbers, and in the end, give me a value, which is a total. And I'm just doing the easy way out, where I'm just checking that this total is not null. But yeah, given how you have configured the random factory, you could also check like the value should be in a certain range and whatnot. This could be used whenever you have, say, any input and you want to iterate on them, apply a function to it, and also reduce the outcome to a single value. So let's just run this. Yes, this works as well. And you can see, well, our random numbers came up to a pretty large number in the end. And that's about it. And that's what I wanted to cover with Java Streams. I hope you will use Java Streams like everyone else and use it to supercharge your automated tests with very quick and robust assertions. I use it daily. I hope you will too. Feel free to try these out in your automated tests and let me know in the comments how you are using them, what methods you are using. And if something is not clear, please feel free to write comments and I'll be happy to address them. Thanks for watching the video, and I'll see you next time.